So certificates, advanced certificates, kind of a question mark there. We'll see how deep we get here. I think the main thing from my perspective when I've dealt with certificates in any job that I've had, it seems like they get a little bit of a bad rep. They're just kind of assumed to be there, or somebody somehow ends up being responsible for them. And then they stand up a weird PKI infrastructure, maybe doesn't follow all the best practices. Maybe you just stood it up because you had to. Maybe Radius Authentication required it. Maybe ConfigMan needed it. Maybe you needed it for some other random project, right? So hopefully we can help a little bit.
That's actually a really good question. Just as we're kind of getting started here with the reactions, do we have any like full-time PKI admins in the room before we go any further and say anything about PKI and CA information? Do we have anybody like does that as their job? Hit the reaction button. I'm just curious to see. It's in the top of the teams there. See if anybody raises their hand. If anybody wants to.
Because we'll totally add you as a presenter.
Okay, cool. Yeah, we will. Like 100%. Like we'll get you up here on the stage, hand you a microphone and everything.
But yeah, so it's a trap. It seems like that's kind of where they end up, right? You just kind of assume they're there, they work, and you maybe follow a little guide. We're not going to get into some deep dive about like how to configure PKI and all that fun stuff, but hopefully we can provide a little bit more insight into what's going on with certificates, some of the caveats and gotchas, all that good stuff. So with that said, what is a certificate? Why should I even care at all? The most friendly comparison I can make is that they can be compared to a passport, right? They are ultimately a form of credential and identification that has some type of validation in there. It says who you are. It's backed by some kind of authority. There's some trust to be assumed, right? And there's some agreements that have to happen to make sure that it's trusted. It relies on that trust model. That's something that you might see. You may be seeing errors around. Oh, this certificate is not trusted. And even that happens for a self-signed sort of scenario. So I believe I stole this snippet from a Microsoft doc regarding certificates. The way they stated it was a digital certificate binds an entity such as an individual, organization, or system to a specific pair of public and private keys that can be thought of as electronic credentials that verify the identity of an individual, system, or organization. Individuals, you've got user certs, you've got your computer-based certs, you've got client auth certs. And you've got that trust model with there. So self-signed certificates, that's something to take into consideration with that trust model. You can generate those self-signed certs and you can use them for a lot of purposes, but they're not going to inherently be trusted compared to a PKI infrastructure-based certificate or a public certificate authority. We'll touch a little bit more on that public certificate authority stuff or PKI based or self-signed. We'll kind of dabble in that as we go. With regards to what it means to be trusted, it ultimately means like you have an agreement, right? That's why your passport is a valid credential. It's a valid certificate because you have a trusted authority, whether that be, the United States government or whatever entity you're getting that passport type credential from. There's trust. It's got some, I'm sure there's some fun magic on the back end of passports that ultimately validates, right? You've got your little barcodes and watermarks and all that fun stuff. So very comparable to digital certificates. And similar to a passport, you've got to and from dates, right? You've got valid from and to. You generate it, and that's when it starts being trusted. And then it ultimately has an end date. Some of those end dates, there's a little bit more to just as simple as being an end date, right? Timestamping is a consideration when it comes to end dates. We'll talk about timestamping as we go through here. And then in regards to a little bit of what a certificate uses for all of this, it's called asymmetric cryptography. So we've got the public and the private key, and that's a theme that you will see throughout. We'll show a little bit of some fun stuff with private keys and some considerations with them. For these public and private keys, they are used as a pair, right? There's a pair. So somebody has the public key and somebody has the private key. The private key is going to be something where it should be kept. It's a secret, right? That's effectively your or kind of cred part of things. That's what's going to be, able to sign things. And then everything on the public side says, oh, I know what this is. I can decrypt it. So that is definitely a key component.
That's actually an important thing too. So that the private key that we're talking about here, if you've ever done something, whether it be like in the publisher or if you've exported a certificate from the store for something or anything like that, when you're exporting the certificate, a lot of the time you'll see like that checkbox, export private key along with this, right? That's the important bit that is talking about here, that if that private key goes along with it, when you do the export along with it, then that certificate has the important bits for signing, things that get exported along with it if you allow it to be exported.
Yep, for sure.
Yeah.
So let's see here. And I did want to show something kind of interesting. I'm going to share out Remote Desktop Manager. So, all of these, is this reasonable? Can we see this? Yeah, decent. Yeah. Awesome. So, we talk about certificates, and on computers, we have these certificate stores, like we see them. And I'm specifically here in like local computer. And we've got, oh, here's my personal certificates. Maybe I've got trusted publishers. I've got my roots, but everyone's just kind of familiar when they deal with certs. They just know that you can open up the MMC. And then within that MMC, I can add in my node for the certificates, right? Whether that's user or computer or service. And in this case, I'm going to add my computer certificates. And then you can see here they all are, and that's a certificate store. But what's interesting about certificates is the actual location where they are stored is in the registry. So we can see I'm in right now. This one's the HKCU, so that would have been if I selected user. We can also go under system. So now I'm under HKLM, software, Microsoft, system certificates. So within system certificates, I have a trusted publishers node. And I have my certificates. And if I'm not mistaken, these are the thumbprints from these certificates, and they are in the registry. And this is the blob that stores them. You can extract this, if you care to, but ultimately, the MMC is doing the work for you. PowerShell is doing the work for you if you do export, certificate. But this is where your certificates are actually stored. So kind of neat to see them. And there's some other areas too. We'll make sure that they're in the slide. You'll find the same for like policies. If we go under, instead of HKLM software, under policies, Microsoft, here's system certificates. Here's going to be your like group policy managed ones as well. So they have a place. They live somewhere, but we don't have any managed by GPO, so you're not really going to see anything here in this environment. Go back to sharing where I want to share. And then alongside that, though, we did talk about that local machine and that current user store. So the big thing there is you have a bit of a permissions barrier. So multiple users can be on the computer. Each of them is going to have their own user certificate store, so that when you dole out your certificates via group policy, for example, you can make those like your client auth certs. Your users can have a certificate. Your users can have that cert, and that can effectively authenticate them to some web service or something, right? Or it can authenticate them to the Wi-Fi. So if you've ever set up like Radius authentication, you're going to dole out those certificates to your users with client authentication permissions, and then they're going to have that key and that key pair that lets them then do authentication and then do that encryption and decryption. So high level, there's a handful of uses. There's some here we're going to dig into a little bit more than others. Secure network communication, browsing the web. Certs are a huge part of the web. And I think one of the really interesting parts about it. It is very transparent, especially as like a typical user or just an at-home kind of computer person. You don't ever care or need to know anything about certificates, right? You don't need to know when Google stops trusting certain types of certificates or expects certain validity periods. Everything just kind of works. But in IT world, we start to care a little bit more. And even then, though, it is largely transparent, which is impressive. But there are some exceptions for sure.
So I think that's actually kind of interesting. Something you were touching on there, Cody, and I wonder if maybe you touch a little bit more on it. Right? Is this like, how do website certs actually work? Right? Because that's a component I think that trips people a lot when first setting up an implementation of something, like even just setting up a basic web server, right, with IIS, and then you bind a cert to it, and you've got the server cert. How do clients actually know that cert's okay for all these miscellaneous certs out there? Because to us, it is transparent. So the certs that get used there are from those public signing CAs, right? I think we've talked about this. We've actually had cases before, right, where like somebody didn't trust a public signing CA as a result and couldn't hit our website actually. Could you dive in? Do you happen to have that store off the top of your head? Maybe we could show that and just kind of touch on that real quick, because it just works on every single machine.
Yeah. So, right, we have trusted root certificate authorities, and these get managed by Microsoft by default. Now you can override them, right? You can manipulate this list, and that can cause you some headache. But also, it's a security component as well, right? Because by trusting these CAs, you're going to start trusting the server auth certificates and things like that come from websites that are signed by that CA. And ultimately, if a CA gets compromised in some way, shape, or form, if it's no longer trustworthy, right, you need to not trust those certs. And so there are instances where you may have to manage these. You may have to say, well, we don't trust these, right? We're going to remove them from all of our certificate stores. Then there's even considerations where like Firefox, the Firefox browser has its own certificate store. It doesn't really care all that much about what's here. It maintains its own certificate store, which has some positive and negative implications. Some people say that's great. Some people say, well, I don't really want to be subject to Firefox's interpretation of what's good and bad in the certificate world. But if we go to, for example, patchmypc.com, we have a certificate, and that certificate has a chain. Here is the extended validation server, which would be like the intermediary, and then here's the root CA, right? So this root CA, I ultimately have to trust this root CA, DigiCert High Assurance EV root CA. And so you will find a root CA that is right here. I trust it. I didn't do anything. This happened auto-magically for me, right? This is going to be on pretty much every computer ever. And so for Windows anyway. And so this is the root for our certificate that we requested from DigiCert. We use them as authority. We requested a certificate. And I should find, similarly, if we dig in, I would find an intermediary if it's needed. In some cases, there's no intermediary or it's implicitly trusted. And so that same flow is actually going to apply to your certs if you use them for IIS, right? So sometimes people will come in here and they will just have like self-signed certs. We talked about that a little bit, like self-signed in that trust model. If you have something that's self-signed, you have to trust it. And if your clients don't trust it, it's as good as it's like, okay, I don't know what this is. No, sorry, cert's invalid. So you can take that cert. I have too many things open now. Close you. And you. No. If you take that self-signed cert and you dump it in trusted root, it's going to say, oh, I know who that is, because I trust that cert. I trust the cert itself.
What type of cert did you use there, and why? So like just kind of expanding on that, right? So like these are all client authentication certs, right? What are all those certs that are on those web pages? And in this case, what are those?
The roots are going to have various purposes. So the one that we were looking at was this one.
Because you were looking at the client auth up there at the top, I think. Yeah, there we
go. So this one is our root, right? That for our Patch My PC website, and we can see that one of the intended purposes is server authentication. So generally speaking, when you're going on a website, you're going to see that it has the server authentication purpose. If you've ever gone in, and I guess we can go look at, I think the EHTTP is on here. So we should see, for example, So here is some of the certs that get generated automatically for Configuration Manager. And we can see that one of the intended purposes is server authentication. So this can get bound and used for some purposes. And I could actually take this and I could totally bind this in IIS. And it'll work for server authentication purposes, but you don't have trust. Because this is ultimately issued by Configuration Manager. So some random web browser or your client isn't just going to implicitly trust it. This came from ConfigMan. Now ConfigMan components will trust it because it was issued by ConfigMan, and ConfigMan says, well, where did that come from? I trust that, right? It has its own mechanism, kind of comparable in a way, a little bit to Firefox. Like Firefox has its certificate set up. ConfigMan has its own infrastructure kind of internally. Maybe you can, DJ might yell at me and say I'm speaking wrong, but that's my understanding. So yeah. Oh, I just closed the PowerPoint instead of presenting. I'll open it back up.
That brings up another thing, doesn't it? With the trust model of a PKI or public CA, when we talk about having that trusted root certificate, and then we trust the certificates that are signed by it, what you'll often find. So this is certainly true for larger orgs, so SME, larger organizations that have a PKI. It's quite common to take that root CA offline, and then just to keep it safe, because it's so important, it signs all the certificates in the environment. If it gets compromised, then that's a bad day in the office. So typically you'd spin up a root CA, and then you'd spin up what they would call subordinate CAs or intermediate CAs. So the root CA would sign the certificates for the intermediate CA, and then the intermediate CA would generate the certificates for the clients. And you take the root CA offline, so you're never compromising that source of truth, because if that ever did happen, every single certificate in your infrastructure would be potentially bad. So it's quite common for a root CA to be kept offline.
Yeah, for sure. Making it sound like I yell at people. Oh, no. He doesn't yell at people. I just make sure he keeps me honest. That's all. I'm just making this up as I go along. So call me out.
So that's kind of like, that's like the document. So I was just going to say, I make that sound really simple, but a lot of organizations don't do that, and that's because that can be tricky to maintain. So I certainly have come across in my previous life as a consultant where we see just one issuing CA, and it is the root CA. And it's often then tricky to backpedal. So if you set up that kind of infrastructure with a single issuing CA that is the root, but then somebody to come along and say, hey, look, this isn't secure because if your root CA was compromised, that's a bad day in your office. Well, then the question is, well, then how do I then get back to the state where it is secure and, create the offline root CA, intermediate CA, issuing CA? And that's a difficult conversation for many admins who are wearing many hats.
Yeah,
I think one of the other things that comes out of what you were just talking about there a little bit, Cody, too, is one of the confusing points that comes up a lot of the time is the difference. And I think we have a slide on this later on, is the different types of authentication types, the different types of usages for certificates, right? And because we have so many interactions every day where we just browse to a website, it just works, that we don't have an opportunity to really break down what does client authentication actually mean? What does client authentication type mean? You would just think, well, everybody needs a client authentication cert to talk to the server, but why, right? And a server auth needs it to be a server, but why, right? Why can't it just use a client auth? It's just validating who it is, right? And the idea is that validation of a server validating who I am to present content back, and the client authentication idea is the idea of presenting who I am, that I'm a legitimate person requesting the content in the first place, between the two.
Yeah, for sure. Yeah. And one thing I kind of skipped over and we'll go into a little bit when we talk about timestamping, code and document signing. So digital signatures, you can see when things are signed. You can go to the properties and there's a digital signatures tab. We'll show that when we talk a little bit about timestamping. And it's it's an interesting thing to see. It's used heavily in WSUS. That's why we're kind of a little bit familiar with it. So, what is a code signing certificate? What is code signing? Up front, code signing is a way of point in time stamping a file and saying this file has these contents at this time, and it was signed by this person. So the file won't be modified. If the file gets modified, the signature is no longer valid. It's not signed, right? So it is just a form of insurance that says that whatever was here when it got signed, it's still there. It hasn't been modified, right? It is exactly what it says it is. With that, though, with code signing, because we're in the Windows world and we've got configuration manager using those certificates, we had the ConfigMan product team come out with something called eHTTP, which made a lot of people's lives really easy. But something fun to keep in mind with eHTTP is that one of the things at the very top of the article is that they say PKI is preferred. Right. eHTTP was the easy button. It is the way for Microsoft to start moving the ball down the road a little bit for a lot of other features where they couldn't just use HTTP, and they knew they couldn't just tell everybody to switch to HTTPS. So they made their own little eHTTP, which is ultimately kind of like a giant self-signed infrastructure for certificates, right? It doles out certificates. It automatically manages them for you. They are trusted within the ConfigMan infrastructure. They still have expirations. They still have all of that. And so ConfigMan does a lot of that work for you. But totally, it says use PKI. It is preferred, but it makes your life easier. The main, and we've talked about PKI versus self-signed, I think, a little bit. I know Jordan is always one to bring it up because it's not black and white. It's not super easy to say that one is better than the other. A poorly managed PKI is not terribly helpful in and of itself. The main advantage of PKI is what's called certificate revocation. You've got a certificate revocation list. So if that's not configured, then that you've lost one of the primary benefits of a
and
PKI
not configured well.
Code. Yeah, not configured well
is another caveat as well that goes along with that. One of the big important things, especially when you're dealing with certificates or anything really security, right, is the idea of confidentiality, integrity, and availability. And when you're dealing with certificates in particular, if you can't assure those three things, you're going to have a bad time in general. If your PKI server is not confidential, it's not well maintained, properly ACLed, you're going to have a bad time, right? If your config manager server has better ACLs and a better stance on confidentiality and security than PKI server, you're probably going to have a bad time, right? If your availability for your PKI infrastructure is poor, i.e., you lose sight of it once you leave the office, or you lose sight of other components for distribution if you don't have a always-on VPN, or you don't have other solutions to be able to access it, or you don't have a public CRL attached to that PKI infrastructure, which diminishes the availability of that infrastructure, you're probably going to have a bad time. Yeah, and finally, if the integrity can't be assured, the integrity of the certificate, the integrity of the communication and back and forth between the client and the issuing server can't be done, again, you're going to have a bad time. So you want to pick the solution when it comes to PKI versus self-signed. Which one makes more sense from that perspective matters probably a little bit more, just in a generalized opinion, right? If I have a PKI infrastructure that every time a certificate expires, we lose entire sections of a network because we can't update the certificate in time, or we can't properly distribute a certificate in time, right? If we can do better job managing a self-sign than we can with PKI, well, that influences the choice. It's not a black and white matter. Yes, there's security benefits to PKI, but sometimes, based on scenario, self-signed or eHTTPS really is better and more secure from a true practice perspective.
And there's often that, I mean, that's a great point. And there's often a disjointed experience as well. So your security admin could be doing an awesome job at creating this really good PKI infrastructure. Certificate revocation is working for clients inside the network and outside the network. And then a server admin comes along, or somebody sets a GPO that disables CRL checking. So that just then breaks that whole story as well. So
and those checkboxes are
something-
littered everywhere, right? You set up a CMG,
Yeah.
it's like, do you want to do CRL? And you're like, nah, no, that sounds comcomplicated. And you check
Yes,
it.
disable
It
it.
has value. It's one of the purposes of a
Yeah.
PKI infrastructure.
Yeah, so
Yep.
I mean, it's something really important to remember. If you're switching off CRL checking, you're kind of defeating. Well, you're not defeating the purpose of a PKI. It's still valid, but the benefits you get over and above a self-signed certificate, that then becomes a less of an argument.
Yeah,
based
for sure.
on what Jordan was saying.
And this is, very specific to code signing, and even more so it is specific to WSUS. But we actually have run into some fun with code signing certificates. We've got an awesome article here that details the wonderfulness that we've come across. So within a WSUS infrastructure, one of the common things you might configure is multiple WSUS servers. And one of the common even scenarios within that is for them to share a SUSDB. They share the same WSUS database, right? You've got two servers, they both connect to that same database, and it has some advantages. I won't bore you with all the awesomeness of WSUS, but there's some advantages to sharing a SUSDB. One of the gotchas, though, with third-party updates. So when you're doing third-party updates, your WSUS server is responsible for signing those updates. It says, hey, I made this. And that's good, right? Cool. You manage it. You say what signs what. You say you trust it. That's really good. But the issue comes in when you've got those multiple servers. If one of them doesn't trust that code signing certificate, you can hit some really odd issues. So within WSUS, there is a handful of different roles that happen. And when you have multiple WSUS servers, different servers can hold different roles. Every 5 minutes by default, there's actually a heartbeat check that each individual WSUS server runs. And when it does that heartbeat check, it puts a little timestamp on those different roles. It's like, oh yeah, yep, I'm good. But what you'll see sometimes is that your other servers hasn't reported back for 5 minutes. Maybe patching took really long on your primary sub. And the secondary one is up and it does a heartbeat and says, well, I'm going to take that role. I'm actually going to take the role that says I do hash validation now. So when you publish an update, one of the last parts of publishing a third-party update is hash validation. It says, oh, is this what it should be, right? Do I trust it and is it correct? And so if it doesn't trust the code signing certificate that got used, it will just delete the update. So we see right here, this is the error that you'll see in the software distribution log. Check certificate signature. It failed, right? It says, I don't trust it. It failed validation, and it will just delete the file. It's not valid, it's gone. And this can be a very transparent thing. You don't really know what happens. You don't deliberately set an NLB master front-end server. It does it automatically, right? Back in the day, you used to set up, load balancing for WSUS. You could go ahead and stand up the Windows load balancer configuration, set up a couple of nodes, and then you could, WSUS was one of those, right? Just like print servers, I think that's deprecated now too. We used to set up network load balancing, and WSUS fully supports it. If you go dig into the commandlets for Configuration Manager, you can still set up load balancing and set that information. It's just not a typical or great thing to configure anymore. So now you just kind of point servers at the same SUSDB, point them at the same content share, and go from there. But this is a gotcha specific to third-party updates. Just make sure you've got that certificate trust. So that article's there. Whenever we notice customers that we're working with multiple servers, we do our best to make sure we get this set up for them as well.
Good one.
So, it was fun to track down. We were scratching our heads for a little while. Oh, you know what? Sorry to keep switching back and forth. I should actually show a signed cab just because I said the digital signature tab. So properties of a file that has been signed, and you don't have to, this isn't specific to WSUS. This isn't something that we just happen to be doing. We can find the exact same if I just grab some random DLL from software. Oh, no, that's not it. DevLab. Hang on, those are not signed. Let me find something from like Notepad++. Serves me. Oh, it's not installed. Serves me right for using my DevLab. I have a bunch of unsigned binaries.
Well, you trust them, and that's what's important, right?
Yeah, I trust them. So here is an example of Notepad++, right? Notepad++ is a vendor, but at the end of the day, you know, they sign. They're going to be responsible for signing this. We can see they have a DigiCert certificate that they are using. There's the issuer for it. You know, we can see that it has a key usage right here for digital signature. They used their code signing certificate to sign this file. You know, so ultimately it says, yep, this is us. We signed it. It has not been modified. You trust that CA. We're responsible for it. And the same thing's happening here. Right? We've got a digital signature on this cab file. We've got the details of it here. I've cycled a few certs, so it looks a little funky, but sure enough, there it is. You know, I trust it. It's self-signed, but I trust it because it's in the right places.
Both of these scenario. Oh, go ahead. Sorry.
I was going to show signing because I just have that pulled up. But yeah, go ahead.
Oh, good. So both of these go back to something mentioned a little bit ago around the integrity of a file, right? It goes back to the concept and idea and security of CIA, right? And what signing here that we're doing here and what signing happens in WSUS as well is it's a goal to ensure the integrity of the file, which is why having the same certificate across both locations matters and why it deletes it, because it can't ensure the integrity of the file anymore because it doesn't trust it. It's a loss of that component.
Yep, for sure. And so with signing, code signing, because this comes up, you've maybe been in ConfigMan or Intune, or maybe just you have security policies. Maybe you've got some security software. You know, you've got some, I don't know, Carbon Black or whatever, and it maybe enforces like execution policy for PowerShell. You know, so right now, let's see what I actually have for get execution policy. I have it set to remote signed. So let's actually do like set dash execution policy. And then let's not do the one that everyone does, right? Let's not do bypass. Let's do all signed as an example, right? So in this session right now, I have an execution policy of all signed. So I'm going to take my little file here, and I'm going to try to run it. Copy as path. Let's try to run it. Right? It says, well, it can't be loaded. The file is not digitally signed. You cannot run this script. I don't trust it. Right? Now, I could say set execution policy bypass, which, okay, fine. Now, signing isn't necessarily a security barrier. There are ways to work around it. But at the end of the day, it's that integrity. It's an integrity barrier. It says that the thing I am running is exactly what it says it is. Can it be worked around? Yeah. I mean, if you want to run something for some malicious purpose, totally. But at the end of the day,
sign Mimikatz.
It's layers, right? It's layers. You know, integrity of the things you know you should be running. There's some validity to that. So there it is, right? I have it. It's not signed. So I'm going to fire up another instance of PowerShell where I do not have that execution policy set. Validate that. Oh, let me just change it temporarily then. 1 second. So I'm going to sign.
There's a question in the chat, by the way, too.
Oh, what is it?
Yeah, it's about the security template in SCCM. Let's go back to that once we're done with this piece here, so we can go look at that template in the ConfigMgr console.
Yeah, fair enough. It's a good question. Yeah, we'll see. We'll take a look at it. So I'm just temporarily doing that. I've got a little script here, sign the thing. It's not doing much. Ultimately, I'm getting a cert. I have a code signing cert. In this case, I am leveraging the one I've generated for the purposes of WSUS code signing. But you can also, you know, manage code signing certificates in your infrastructure. You can dole them out to people that write PowerShell if you want. But I'm going to grab the cert. I've got a file that I want to sign, and I'm just going to use this PowerShell commandlet that's convenient and handy, set-authenticate signature. You provided a cert instance, which we'll look at a little bit. If you want a timestamp server, that's our next slide. An algorithm if you wish to specify a specific one, and then the file. The hash algorithm thing is kind of a fun little thing because the more complicated, the larger the hash algorithm, the more resource intense it actually is. So if you have never had HTTPS configured in any way, shape, or form in your ConfigMgr environment, and then you flip it on, and maybe you, for some reason, decide like I want like SHA-512 or whatever. The more complicated that hash algorithm, the more resource intensive it actually is. So you might see your management point start to actually bump up in resource usage. You're going to see more that crypto service. You're going to actually see it start just churning. You're going to see it use more resources. So something to keep in mind, right? Yeah, I mean, it's nice to be more secure, but on the flip side, you don't need like a SHA-2048 or something crazy that might not even exist. There is a little bit of a diminishing return there.
Yeah, absolutely. And I'll also say that stronger isn't always best, and stronger can break. I've had experiences before where gone to create a really complicated hash algorithm because you think it's uber secure, and then find out you didn't read the documentation and the vendor doesn't actually support that hash algorithm. So read the docs.
I got to throw the correct one. So I'm going to run this as sign the thing script. So we see here's the signer certificate. This is the output from set-authenticate signature. It's valid. This is the file we signed. Now, if I go and I reopen my little file there, it changed. It has a signature. It has a signature block now, right? Everything looks good. And then also, if I check the properties of this file, it now has a digital signature and it has a timestamp. And I can view the certificate and I can see that it's my cert ultimately. It's the one that I used, and here it is. I found it, right? And so now if I go back here, let's go ahead and just double check. Set to bypass. Let's set it to all signed again, right? It works, right? I now have my execution policy set to only signed files. And now I can run my signed file. I don't need bypass. I trust it. So woohoo. Now, so integrity, right? Let me change it.
You guessed exactly what I was going to mention. What happens if we delete a line from that, though?
Yeah, so maybe let's leave the block. That's fine, but let's change it. Let's change it to hello world, right? And then I don't know, maybe thanks for all the bacon instead, because bacon's good. And let's try to run it. The content of the file might have been changed by an unauthorized user or process because the hash of the file does not match the hash stored in the signature. The script cannot run on the specified system, right? So part of that block, part of code signing is ultimately the hash of the file that is in that signature block. That it's the hash of the file, and so that hash, depending on the algorithm you use, is also going to be bigger. That signature block size is going to change. If you signed that with a smaller or a different algorithm, it could get bigger or smaller, right? And then also, it's going to take more effort to encrypt it and decrypt it, more resources. Client side, who cares? Your web server that's doing tens, thousands, millions of requests, well, now I care.
That's another good thing actually to note too, is something we probably could have showed this. We probably could show it again if we wanted to real quick, if you wanted to rerun it, is that file size will change. It will always get larger when you sign something. If you sign something and it gets smaller, you have a problem. Because it's always adding the block to the end of it that translates, or how to translate it back, which goes back to what Ben was mentioning earlier, right? If you had this really big methodology of encryption, you might make the file way bigger than you intended to, too.
Mm-hmm. And that can have issues. We've seen issues with particular cloud services where when you start signing stuff and file size grows, and then you find you hit a very low threshold on the amount of text you can put in a JSON file. Yeah, it can make a difference. Those large signatures.
For sure. What are the ones they actually provide? Now that I think about it, I was going to see if I can make it bigger or smaller. Oh, they don't actually tell you. That's annoying. It's not like an enum. Okay.
You could do like an MD5 just to.
Yeah, that's true.
I think the interesting thing as well that this should make us think about is when we get files from our software vendors, are we checking to see if there's a digital signature? Because if there isn't, then could potentially the software be subject to a man in the middle, because we don't know whether the software actually came from the vendor and is the source of truth, you know? So that's something
Mhm.
that is worth thinking about. I've downloaded
So we
this software from the internet. It's not digitally signed. Can I 100% guarantee that this was written by the devs in that company?
Good point.
We have an
There it is.
interesting question in the chat there too, which is if you change the text back without restoring it from the backup, like so if you change the text to something wrong and then you change it back and then you run it, does the signing still work for it?
Oh yeah,
Yeah.
yeah, that's fair. We can try it. So I think one thing to keep in mind with that too is encoding even matters. If you change the encoding of the file, your hash is even going to break. But we can try that real quick. Why not?
It should stay the same because it's the content that's
Mhm.
getting hashed. It should work, right?
Yep.
But we can go through and prove it. It should work. The update or change time of the file shouldn't matter because you can rename a file. You can accidentally cause modified by or modified time changes through a number of things.
Yeah,
It
for
should
sure.
work though.
So what I'm going to actually do too is change it to SHA-512, and then we'll go run that.
How big is the
Nope.
file now beforehand?
Oh yeah.
Too late.
No, I didn't. I ran the wrong one, so we're good.
Okay. Oh, phew.
Yeah, 63 bytes, right? Is the current file, and that is let's open it with Notepad because the ISE is being a little silly there. It's not reloading it. Yeah, so it's not signed, 63 bytes. We'll sign it with 512. Should see that it is markedly larger, right? Quite a bit actually. And then if we look at the contents of it, go ahead and see that there is a even more sizable block, signature block here, right? It's a larger block as well. And then let's change it, save it, and we should see that it's no longer valid if I go to run it. Yes, A. Right? Cannot be loaded. Content has changed.
Yep.
Now, if I change it back, as long as I didn't change encoding, yeah, it trusts it, right? And you know, again, file name doesn't matter either. That's okay because that doesn't impact the hash.
It's only the contents inside of it that matter. The metadata, not so much.
Yeah. Do you have to? Yeah, I think Andrew answered it. That's a good question though. Do you have to delete the block before re-signing it? You don't. It will just go ahead and just overwrite the block. Yeah. So
you can also sign over the top of an existing signature as well. So if Cody wanted to grab another cert, if there happened to be another cert that was in there from some other trusted source, you could totally use some other trusted source and sign right over the top of it. The existing block would go away and the new block would get replacing it. Wait, before you go away, Cody, we had another question we promised we would jump back to before we left on ConfigMgr and certificates and expiring certs.
I don't know if I have the answer for this one, to be honest with you. I want to say it just works. So I assume we're talking these, right? Administration, security certs. So this is, in some aspects, a little bit of that internal ConfigMan managed certificates. You usually won't have to come in here and do much of anything. By the time they expire, ConfigMan is just going to renew them and make sure that all the necessary components have them. Now, if you have PKI managed, you might come in here and you will see your PKI managed certificates in here. And ConfigMan's cool, but it's not that cool. It's not going to magically renew your PKI issued certificate and rebind it or something, right? So, if you don't have anything for like full HTTPS and you're not assigning certs out, more than likely you won't have to come in here and do much. I've seen some edge cases where certificates for third-party catalogs get blocked. You may have to come in here and unblock them. But aside from that, this should be pretty hands-off. If anyone's had some trouble, I'd be interested, but yeah.
One other thing I have seen in here is if you are using a PKI certificate and that certificate expires and you have ConfigMgr configured to automatically generate and manage a certificate, if the PKI provided certificate expires, ConfigMgr will generate a new one that is not expired and start distributing it.
Yeah, that's a good call out. So Ben, was actually asking a little bit about like what are some of the implications here, right? So this is awesome. This made third-party update catalogs much more palatable in ConfigMan. You know, before this, it was like, oh, okay, use SCUP and all that fun stuff. This was a big breakdown of barriers. This top one right here, this will if you have an expired PKI issued cert, ConfigMan will totally say, hey, look, you told me to manage it, and it's going to generate a WSUS self-signed one, and it's going to use it, right? And it will make it seamless, generally speaking. If everything is configured correctly, it's going to use it. It's going to store it in the ConfigMan database. It's going to be in the WSUS certificate store. And then based on your client settings, it's going to distribute it out to all your clients too. So realistically, you might not notice which good bad a little bit, right? Because maybe you just changed from PKI issued to self-signed, and sometimes you may have a company mandate or some sort of contractual obligation to use PKI issued certificates where possible. So food for thought.
Yeah, and like another thing, like if you're maybe you've generated your own self-signed certificate and you've made the private key exportable, and we talk about this sometimes, like if you want to maybe move WSUS to another server and you don't want to change your signing certificate, if the signing certificate is exportable, that's quite easy. The config manager by default won't mark the key as exportable if it generates one. So that's just something to bear in mind. And it's not the end of the world. It just means that if you move WSUS, you're just going to have a new code signing certificate.
And at the end of the day, what WSUS actually does to make those certificates is, I don't remember if it's here or if it is under Git configuration. So 1 second. I think it's nested under Git config, if I'm not mistaken. Yeah. Sure, all 100 and something of them.
It's fine.
Git content. Where is the signing certificate? There is a get. There it is, get signing certificate. So now I have this $config variable. This is really so I can do get. Here is get signing certificate. This is a method that is available within like WSUS, within the WSUS SDK, within the WSUS commandlets. This is ultimately what ConfigMan will run in order to get the certificate when it generates it, and then it needs to get it. And so it can do this. And so I'm going to just toss it in like C temp thing dot sir. Except I need to go make that. There we go. Here's my code signing certificate that is configured in WSUS, right? I found it. This is the one. Now, when it does this, you don't get the private key because you don't need it in this instance. You're just asking for it. And similarly, how does ConfigMan make it? Set signing certificate, right? This is what it does. It just runs this. Now, the thing to keep in mind, this is where the HTTPS requirement comes in play, because you've maybe seen that error in the logs. You've maybe seen it in the docs where it says, oh, if you want to do third-party updates, you need an HTTPS sub if it's remote. If you try to run this, if you connect to a remote HTTP sub and you try to run these set signing certificate and get signing certificates, it'll throw a little error that says, hey, like I can't give you this cert because it's not it's not HTTPS. You're not connected to it securely. So it'll toss that little exception. So that's where that prerequisite comes into play.
That's awesome. And we were also playing through the scenario earlier, weren't we? Where okay, let's say you've generated your own self-signing certificate to sign updates with in WSUS, and then you're very proactive and you monitor the end of life of your certificates. You're like, well, hey, our code signing certificate expires in a few months. I'm going to generate a new one. And then what happens in the instance? Mm-hmm. So that's a question we've had asked before. So I've got my existing code signing certificate in the WSUS store and it's valid and it's in WSUS and it's signing files fine. But then I generate a new one that's newer and into the WSUS store. What happens in that scenario? And you were talking us through that, Cody, weren't you?
Yeah. So it goes back to being seamless. Generally, the only consideration that I think is a little bit of a concern is is, you're going to potentially have third-party updates that were signed by that old code signing certificate. And that was all fine because ConfigMan was aware of it. It was getting distributed through client settings, and your clients trusted it. Your clients got it in the Trusted Publishers store, and then if it was self-signed, it also ended up in like Trusted Root, right? But once you change certs, ConfigMan says, oh, I got a new cert. I'm going to start giving all of your clients this new code signing cert. You probably have third-party updates that are still signed by your old code signing certificate. And that's going to actually cause you some headaches because your new clients aren't going to get your old certificate. So your new clients aren't going to trust your old updates. It can cause a little bit of a headache. You can go manually distribute out that old certificate as needed. Our tooling has some re-sign options as well if you do run into that scenario. But it's something to be mindful of. It'll creep its head up.
Defo, yeah, it's a great call out.
Yeah, for sure. Let's see here. I'm not going to pop up the slide just because I can kind of show it here as well. And then I'm going to pass it off to Ben because we are chipping away at our time block here. So timestamping, we've talked about it. I've kind of shown you, hey, here's a timestamp. But timestamping has a pretty important purpose. When you timestamp something, the timestamp is, and this is just straight from Wikipedia, it is a trusted timestamp is a timestamp issued by a trusted third party acting as a timestamping authority. It is used to prove the existence of certain data before a certain point. So that last part, I think, is the key. So with that, you have it's that point in time aspect, right? So if I signed something on December 1st and it was timestamped December 1st, and then eventually that certificate is going to expire. Once it expires, if you still trust it from like a chain of authority kind of trust, even though it's expired, it's going to evaluate that timestamp and say, well, you know what? Yeah, it's expired, but I have a timestamp. This tells me this file was signed at this time. The certificate was valid at this time. So now I can still validate and say that this file is in a usable state. And so that helps a little bit with certificate expiration. So if you have old updates signed by an old cert, as long as they're time stamped, you're in good shape. Your clients are still going to trust it, right? So that's a little bit friendly. You don't have to worry about a 1-year rollover code signing cert as long as you're time stamping. But there's an interesting gotcha. If you use in council publishing, they don't timestamp them. And they don't timestamp them for a real fun reason. There is a aspect of WSUS to keep in mind. When Configuration Manager uses the crypto API to do code signing of CAP files, it's going to use the system level proxy. And it is not the most common thing in a infrastructure to configure the system level proxy. It's very common to just do the user one, right? Maybe you've got a pack file set up, maybe some group policies. So if your system is not using the proxy and you need that proxy to hit the timestamp server, it's not going to work. It's going to fail. And so, we provide the tooling to let that all happen, and we do our best to support that. But it is a fun little gotcha, and that's, from my understanding, one of the main justifications for ConfigMan, for example, not timestamping third-party updates.
Spot on.
But if I'm not mistaken, I've talked enough. I'm going to pass it off to Ben. He loves Azure app registrations.
That's a bit heavy. I'm not sure love is the right word. So we thought we'd cover this as well because, certainly part of the Patch My PC solution, you can use a certificate as well for your Azure app registration. So we need this service principal. If you're publishing updates and apps into Intune, we obviously need the graph permissions to do that. So we're writing everything with graph. So we would typically create an Azure app registration to do this. And I just want to talk about a couple of the different options we have for authentication to that service principal. I think we've already touched on kind of the difference between public PKIs, internal PKIs, and self-signed. So I'm probably not going to spend too much on there. And then we can show a bit of PowerShell as well. So your Azure AD application registration for the purpose of authentication can support two types of auth. So when you're using automation like PowerShell, so we can either use a client secret, which is essentially just a password, or we can use a certificate, and we all love certificates, which is why we're all here. So typically for an Azure app registration, a lot of people would use client secret just because it's easy. Now, the only problem with doing that is essentially at the end of the day, it's just a password. So if you're securing your Azure app registration with a client secret and somebody else gets that client secret, they could use your app registration to do the things that the app registration has permissions to do. So in our case, let me run through a scenario here. If, for example, you're using the Apache My PC publisher and you're using client secret for your app registration, which is fine. What I always say to people is make sure that wherever the publisher is installed, you treat that as a tier 0 device. Because if somebody gets onto that box and is doing some kind of DPI SSL and they're sniffing headers, you can actually see that client secret in the header going to the internet. And if they've got that, they could potentially write malicious apps into your tenant. So it's very important to make sure that it's secure. And certificates are a much more secure way of doing that authentication. Because if you think about it, a password is just something you know, and anybody can know the password. And a certificate is something you have. And that's what's really great about certificates. We're talking about the asymmetric key pair again. So you have the private key for the certificate, and the public portion of the key is uploaded to the Azure app registration. And only you with the private key can do the authentication to get the token to make those graph calls. Can we go next slide? Are you still presenting, Cody? Next slide, please, sir. So we've kind of touched on this already. If we're going to use a certificate for app registration, do we use a self-signed one or one from a PKI? We've kind of had that conversation already.
This is straight from the Microsoft Docs for what it's worth. They walk you through kind of how to do this, and this is right up top in red.
Yeah, they quite rightly call it in their docs. A certificate is better for authentication than a client secret, and for better security, use a certificate signed by a well-known CA. So they're kind of talking about public CA or an internal PKI. But again, like we said earlier, if you've got no CRL checking, why would you use an internal one? So what I'm going to show you actually is how to create a self-signed certificate and use that for your Azure app registration authentication. It's fairly straightforward. So next slide. So we can use a PowerShell commandlet, new self-signed certificate, to create a certificate, and that's going to create us the certificate with the private key stored on our machine, so we can use that private key to do the authentication to grab our token. And we're also going to generate the public portion of that certificate as well, which we can upload to our Azure app registration. And there's a few things just to bear in mind when you're using certificates to authenticate against Azure. So I've just lost my slide I'm on here. Seconds. Cool. So we have to be using the RSA cryptographic algorithm. I'll just go, I think we've gone forward a slide. Let's go back a slide.
That's my bad. Go ahead.
Yeah. So by default, when we use this commandlet, it's going to create a 2048-bit key length key. Azure AD only supports RSA, but this commandlet will create the RSA cryptographic algorithm by default, so we don't need to worry about parameters to do that. SHA-256 hash algorithm. Azure AD does support SHA-384 and 512, but 256 is fine. By default, this commandlet is going to create a certificate that is valid for 1 year unless you tell it you want it for longer. So if you're going to use this method to create a certificate, just bear in mind that it will expire at some point. But Jordan had an interesting thing on that, didn't you? About
I don't know what you're talking about.
Validity for. But what did you find out earlier?
We found out that you do actually need to have the entirety of the certificate in order to properly be able to authenticate to the machine. So there's some interesting things with how the certificate appears in Azure and with how some of the docs are written that make it look like you might be able to authenticate without having the entirety of the certificate. And what we found was so we did some testing. We actually did some testing right before this call to see what do you really need in terms of access to the certificate to authenticate to the Azure web, the registration, the Azure app registration. And we found you do actually need the public key and the private key for it. And you don't, however, need to have a certificate that is current. You don't have to have a certificate that is current. That means that if the certificate has expired, so let's say that the expiration date for the certificate was set to yesterday, that certificate, as long as you still have the public and private key, you can still authenticate to the Azure app registration with it.
Very valid point. I'm going to jump into the lab. That's as much as I'm going to do in PowerPoint, I think. Cool. I put some more in the decks, but that's if I kind of passed out from too much Red Bull. We could show the decks instead.
I think we kind of walked through these steps. So
yeah, let's show you some code. So actually, just put it on the screen for a second because we're going to. This is recorded and people may want to just see that code on the screen. So let's step through it quickly. So we're setting some params early on. So I'm just setting a common name on the certificate. I'm specifying a folder where I want to dump the public portion of the certificate and the PFX if I want to export the private key. And in this example here, I'm setting a validity period of 2 years over default 1 year. And so we're using that command, that new self-signed certificate, just to generate ourselves a key. In the lab, I'm going to export the public portion and we're going to upload that to Azure. We can also export the private key as well, because when we generate this certificate with PowerShell, it's going to place that certificate into the local store. So I'm going to put it into the local machine store. So when I use PowerShell or the system context to do any kind of grabbing of certificates, it's going to use that local store. But if you want to do any kind of authentication on a different machine, you will need to export that private key as well.
Yeah, for sure.
Just show the next screen so it's on the recording, and I'll go through it in the lab.
Yeah.
So the export of the private key code.
Here's this. Oh, this one right here. Export PFX.
Yeah,
okay.
Yeah. So the method I'm going to use now to create the self-signed certificate, if you want to export as a PFX, this is what you do. Cool. Let me share my lab now. Let's do some fun stuff. So, okay. First up, is that clear? You got me, yeah?
Yeah, that looks great.
Awesome. So I'm signed in as admin. I'm using ICE. So I'm just going to run this code. So that was pretty painless. So it's created me a certificate. If I go into my local certificate store and hit refresh, see the CN I was creating earlier up here. I can see that certificate has been created. So it has usage, client auth, and server authentication. Doesn't really matter for me at this stage. Okay, so this is the private key installed on my machine. So I need this to be able to do the authentication to Graph and to get that token. What I also need to do is export the public portion of the key as well into a folder. So I'm going to run this bit of code. So I've now got the .ser file. And if I go and have a look in Explorer, here it is. Here's the one I just created. This is my time in the UK, 1707. So this is the portion I need to upload to my Azure app registration to do authentication. So let me go into Azure AD. So I'm going to go into app registrations. So if I'm using Patch My PC in this instance, I go to certificates and secrets on the left. You can see I've got a client secret here that I've been using in my lab. And here's a certificate I used earlier to do my testing. But I can upload a certificate here and point it to that public portion, the certificate that I created. So I say add. That's cool. So I can actually authenticate with 2 certificates here. There's one I made earlier. So then what I'm going to do is get the thumbprint of the certificate that I've just generated. So still in this same PowerShell session. And I'm just going to connect to Microsoft Graph using the Microsoft.graph PowerShell module. Cool, and I've authenticated. So I've authenticated against, so this is the client ID for the Azure app registration I have. I'll just show you that, so there's no smoke and mirrors. So I don't mind if this is recorded because I'm going to bin this afterwards. So ends in 77, ends in 77, and I'm connecting to my tenant by ben.com. So I've made a successful authentication to that Azure app registration using a certificate. Now, one of the interesting things that Jordan brought up earlier was, as a user on this box, can I authenticate to Graph using that same private key? So this private key is in the local machine store. Okay, so if I open up, I can see under local computer, there's the certificate with a private key. So if I just open PowerShell as a normal user and I'm going to grab the certificate thumbprint of the certificate I created earlier. So this is in plain text. And I'm going to try and make that connection to Microsoft Graph as well as a normal user. Cool. So this error I've got here, key set does not exist. What that is essentially saying is that I don't have permission to get the private key from that certificate. So my user context doesn't have permissions on the private key. So what I can do is I can prove that as well. If I go back into my local certificate snap-in, look at the certificate, and I can actually manage the private keys from the MMC. And I can see here that only administrators and system have permission to read that private key. So what I could do, and this is why you have to be careful and treat this as a tier 0 device. Don't let everybody log on to this box, because if they have admin permissions, they can modify the private keys. So actually, I'm just going to put.
Yeah, right. You could almost consider this as like a form of persistence, right?
Yeah.
I'm sure there's a very long list of people that are monitoring the ACLs of all of their certificates, private keys. So.
Yeah, absolutely. So I couldn't authenticate before. I've just given myself permission on that private key. So if I try and make the same connection again, let me just grab the certificate again. Oh, that's interesting.
The demo gods have thwarted us.
I've done it on the wrong certificate. That's why. Let me set the private key permissions on the correct certificate. Hey, I'm human.
As a side note, Ben, when you talk about tier 0, are you referring to like PAW standards for a machine or something else?
I would suggest so, yeah.
Okay.
Or if not PAW standards, at least something similar.
I would, yeah. So I call it, different terminology. I say tier 0. So you have to have, don't make these kind of calls with certificates from a laptop. That's the kind of thing I'm saying. If you're making connections to Graph from laptops and you're a local admin, that could end up pretty bad. So just making sure you're making these calls from a secure box is what I'm saying.
Yeah, for sure.
Because we can intercept headers. We can do. You can do it yourself. You can go and download something like Fiddler, do a man-in-the-middle inspection of the headers, and you can see client secrets flowing backwards and forwards all day. And what I'm saying is, if somebody has the private key, or somebody knows the secret for this Azure app registration, so these are the API permissions I have for Graph. So I can read in my apps. So what's stopping me going to create a malicious app and then making it as required to all devices? So I'm just saying, just be conscious of the privileges you have as an admin.
You should basically think of this certificate for this as username, password, and multi-factor authentication, all conveniently tied into one single file that lives on a box.
Yeah, absolutely.
Yeah, for sure.
That's what it is. It is username, password, and MFA for anything that API is app registration is capable of doing.
Yeah,
Exactly.
a couple questions. Yeah, I think we will be able to share the script. We'll share the slides. We do record all of these. They end up on our YouTube channel. So yeah, for sure, no problem there.
So again, I don't mind sharing this because I'm going to destroy this app registration afterwards, but don't show people your app IDs. I'm going to pick, so I have previously used the client secret to connect to this Azure app registration. So if I was to patch my PC customer and I want to choose a certificate instead, I can totally do that. And we will actually, this is an awesome feature, we will actually call out the expiry of that certificate, even though it's maybe not relevant for Azure. It's still pretty cool. We can also show you the expiry for the client secret as well, which is pretty cool. So I can still do my test, and I have permissions on that app registration for all those API calls. So yeah, it's pretty cool.
Yeah, for sure.
Maybe consider looking your app registrations as a takeaway. If you're using client secrets, certainly don't store those client secrets in your scripts. If you're doing any kind of automation, certainly steer away from that. Maybe look at using Azure Key Vault to store your client secrets. But if you can, maybe think about using certificates.
But
Yeah,
also,
for
if
sure.
you do move to using certificates, don't store your certificates in easy to reach places.
Yeah,
No.
yeah. A poorly stored certificate is no better than a poorly stored client secret.
Yeah.
Yeah.
But yeah, hopefully we've demystified at least a little bit. Like I said, we're not going to have a deep dive into PKI infrastructure configuration and offline CA best practices and all kinds of fun stuff. But with any luck, we've presented some relevant information about certificates for ConfigMan admins, for Intune admins, right? Code signing and a little bit of client auth and server auth. What's PKI versus self-signed? Where do these things live? What are they actually used for? Maybe some pieces that are just a little bit more helpful in a day-to-day job scenario. So yeah, and I think if anybody's got any questions, and feel free to toss those out there. I think we've been answering them a little bit as we go along. To reiterate, yeah, it's recorded for sure. We toss these out on our YouTube channel. It won't be immediate, but we'll get it out there.
If is it okay if I share that PowerShell code for creating those certificates in chat? Just don't go ahead and change production straight away. Just maybe look at it and learn from it. Maybe make some improvements and send them to me. I'm happy with that. So I'm happy to share that code out in the chat. Sorry, it's just killed chat completely, but you just want a quick copy and paste and don't fancy just typing it out from a recorded screenshot.
Do you see any thoughts on third-party patching and co-managed? So Azure versus ConfigMan, MemCM. You can achieve the same goal in both. It just depends on what's sitting in your environment. Both of them properly configured, you should be able to achieve similar compliance. I guess maybe there's a bit better native reporting out of the box in ConfigMan, even if it is SSRS. You do have a lot more data. There's a lot more rich data in ConfigMan land, right? It's all at your fingertips. It's just in a giant SQL database. There are a lot of awesome tools for Intune. The data is, at least up front, a little bit less rich, but that doesn't mean it's unachievable. It can be done.
Yeah, and to expand a little bit on that too, is it really, really, really depends on what are you patching. Are you patching just workstations? Are you patching workstations and servers? And what are your compliance goals with that, and what are the metrics, and how are you supposed to drive those metrics and goals too, right? Because the conversation for how well you can patch something in a co-managed environment starts to shift and change, right? It might be that the answer is actually, yeah, in co-manage, you should totally use both for patching. You should do split brain, right? Do the technical name for it has escaped my brain. Dual scan, right? Maybe you need dual scan, right? For your particular configuration. Trying to patch servers, unless you have gone down the rabbit hole of setting up Azure Arc and yet a whole other solution system and everything else combined with it, trying to patch servers and workstations in a co-management state can be a adventure with how you're trying to do that. So it's a really hard question to give a one size fits all as to what's better. It just depends on what you have. If you only have 500 workstations and you're in co-managed, then patching with that Intune probably makes sense, right? Using Windows Updates for Business probably makes the most sense. But if you have
I'm
a
a little-
mixed bag, it might not.
Curious about dual scan being deprecated. I think the language might have changed, but the ability to scan against multiple sources is, yeah, okay, yeah. So the language has changed, but I think that, yeah. So we're talking about that, right? You can change which components of go out to which sources. So yeah.
Yeah.
Yeah, and the interesting thing
policy
as
still
well
calls
is
that though. Okay, sorry.
it's kind of so with what I always say with Intune reporting is, so Intune reporting is what it is, and so at a point in time you probably know what's happened, hopefully, if the client has reported back its status. The one thing that maybe you're missing is that kind of trend analysis over time. So at this point, what was the patch status of my machine? Okay, and at what point was it patched? So that kind of rich history is something that we don't get natively in Intune, and there's some really great community solutions on, you know, sending stuff to Log Analytics to get that kind of historical analysis. So patching from Intune, third-party patching is easy and it's great. Maybe just try and understand what kind of compliance reporting you want from it as well, and just have a look at what's available and what you can do. That's the one thing I'd say. So the mechanism, very similar. You get the end result, the patch is installed, but how do you want to report on that?
For sure. I believe we will end up firing out some feedback. You know, we're always open to hearing about topics for these webinars as well. You know, we try to source them a little bit internally, and we always want to hear from you all the types of things that would be interesting to hear about in these webinars. I know this is you know, it's not always about our product, right? You know, we tie it in a little bit. We're going to talk about code signing. We're going to talk about how we use code signing. We're going to talk about you know, some of the advantages that we have, right? We timestamp our stuff, for example, when you publish through our publisher. But the ultimate goal here is just, you know, community outreach, community engagement, right? We love working with the community. A lot of us are, you know, part of the community, and we you know, we've all benefited from this. So topics are great. Love that.
I think that's it.
Awesome.
Attendance was
Cool.
really good, but it's like it's dying
Yeah.
down now.
Thanks everybody for coming along.
Yeah, thank you all very much.